You ever get that feeling? Like you just constantly bombarded with new AI stuff. Every day it's another breakthrough, another game changer. And honestly, trying to keep up with it all, well, sometimes it feels like trying to grab a fistful of smoke. It's just, it's tough. But today, we're digging into something pretty fascinating. It's called CodeAct. And we're going deep, like really deep. Let's see if we can make sense of all the hype, shall we?
Yeah, no doubt. The sheer volume of AI news can be overwhelming.
Yeah.
But with CodeAct, what really grabs you is how it flips the script on what AI agents actually do. We've been used to AI that spits out text or maybe structured data to kick off an action somewhere. But CodeAct, it's different. CodeAct agents actually write and run code, like real code, Python, JavaScript. That's their main way of getting things done in the digital world.
So hold on, let me make sure I'm getting this straight. You're saying these AI agents aren't just talking about doing stuff, they're actually coding their way to making things happen. That sounds incredibly powerful, if true.
Oh, it's true. And it's powerful, all right?
For this deep dive, we've got a pretty good spread of sources. We've got the original research paper out of Apple and the University of Illinois Urbana-Champaign, which kind of got this whole CodeAct ball rolling. We've dug into the documentation for some real-world tools like AgentScript. And we've even got some insights from folks who are out there building with CodeAct using frameworks like LangGraph.
So our goal today is pretty straightforward. We want to get under the hood of this whole CodeAct thing. We want to understand how it works, what makes it so different from other AI approaches, and what the potential upsides are, and all of that without drowning you in a sea of technical jargon.
Yeah, exactly. We want to make this accessible, right?
Right. Now, I know you've been deep in the CodeAct trenches, so can you give us the layman's explanation? What's the core idea here? Sure. So the fundamental idea behind CodeAct is actually pretty elegant in its simplicity. We've got these large language models, these LLMs, right? And they're incredibly good at generating texts, including code. CodeAct essentially says, why force these LLMs into these rigid, predefined boxes for actions? Why not let them use their natural code-generating abilities to actually get things done? I mean, these models have been trained on mountains of code. It's almost a natural extension to let them use that skill to drive their actions.
Okay, that makes sense. So instead of the AI just deciding what needs to happen, it figures out the how. And the how is literally writing code, real executable code in languages like Python or JavaScript. Am I tracking so?
Absolutely, you're spot on.
So this code isn't just theoretical, right? It actually gets run. It's executed in some sort of controlled, safe environment. I imagine it's like a digital sandbox where the AI can play around without breaking anything in the real world. And this immediate feedback, the ability to see the results of its code right away, that's got to be a powerful learning loop for the AI, don't you think?
You got it. It's exactly like that. You've got the LLM, the architect, designing the action in code. And then you've got a code interpreter, usually a Python or JavaScript runtime, acting like the builder. It takes those instructions and executes them. The results, success or failure, are right there in front of the AI. It creates this really tight feedback loop, which is essential for learning and improvement.
Now, this is where things get really interesting for me. Because by grounding the AI's actions in these established programming languages, suddenly these agents have access to this vast ecosystem of libraries and tools that already exist. I mean, think about it. The power of Python libraries for data analysis, the sheer number of web APIs you can access with JavaScript. It's like giving the AI a universal translator for the digital world. They can interact with almost anything that has an API or a library.
It's a huge game changer. We're talking about blowing the lid off those old limitations of pre-programmed actions. CodeAct opens up virtually limitless potential in terms of the tools and capabilities that an AI can leverage. And to understand how this all works, there are a few key pieces of the CodeAct architecture that we should unpack.
Okay, let's get into the nuts and bolts of this thing. What are the core components we need to understand?
Right, so at the heart of it all, you've got the LLM generation system. This is the brain, the intelligent core that's actually responsible for writing the code. It looks at the task, the current situation, and figures out the code needed to get things done. Then there's a code interpreter, which is that secure sandbox environment we talked about. That's where the code gets run. And then there's the tools library. This is essentially the collection of functions and resources that the agent can tap into through its code. It's like its toolbox. We also can't forget about state management. This is crucial because it allows the agent to remember past interactions. It keeps track of variables and information so that it can maintain context over time. And last but not least, there's the feedback loop. This captures the results of the code execution, including any errors that might pop up. This feedback is then fed back into the LLM so it can learn and refine its approach.
It sounds like it's not just a one-and-done process, right? The AI doesn't just write some code, cross its fingers, and hope for the best. It's more like an ongoing cycle of observation, planning, coding, execution, and then learning from the results. Can you walk us through a typical execution cycle for a CodeAct agent?
Absolutely. So it usually starts with an observation. This is the initial input or data that the agent receives. It could be a user's request or some information about its environment. Based on that observation, the agent does some thinking. We call it chain of thought reasoning. It's basically figuring out the steps it needs to take. But here's the key difference. Instead of planning a bunch of calls to predefined tools in a structured way, it translates those steps into code during the code generation phase. Now remember, we're talking about real Python or JavaScript here. Then, this freshly generated code is sent over to the code interpreter for code execution. After the code runs, the agent observes the result. This includes any outputs, successes, and importantly, any errors that might have occurred. And that brings us to the iteration stage. Based on the results, the agent can either decide, hey, I'm done, and give a final answer, or it can go back to the drawing board, refine its code, fix any bugs, and continue working towards its goal. This whole cycle can repeat as many times as needed.
So this whole ability to generate and execute code on the fly, that seems to be the real game changer here, right? It's a fundamental shift from those older agent frameworks that were limited to a fixed set of pre-built functions. What are the specific advantages of using code as the primary way for an AI agent to interact with the world?
That's where the real magic of CodeAct happens. When an LLM generates code, it can chain together multiple function calls in a really logical, predictable way. Think about the traditional way of using tools. You might have to call one tool, wait for the response, then based on that response, figure out which tool to call next. With CodeAct, the LLM can potentially plan out and execute several of these steps within a single chunk of code. And there was this great quote from one of our sources that really nailed it. This code calling allows you to save results variables and then reuse them. This ability to store and manipulate data right there in the code, along with things like conditional logic and looping, that's where you get this whole other level of complexity and capability. Agents can now combine tools in ways that we might not have even thought of when we designed them. Instead of being limited to a preset menu of tools, the AI is given the whole programming manual and told, go nuts, figure it out. This opens up a world of combinatorial possibilities for actions that just weren't possible with those older predefined tools.
So instead of us humans having to imagine every possible action an AI might need and then program it in, we're essentially giving the AI the building blocks, the programming language itself, and letting it figure out how to assemble them to solve the problem. It's like going from a basic calculator to a full-blown computer.
Exactly.
Yeah.
And we're already starting to see this approach being used in some really cool real-world applications. Let's take a look at some examples of how CodeAct is actually being put into practice.
Hit me with them. Where are we seeing CodeAct making waves?
Well, we have to give credit where credit is due. That early research from the University of Illinois, Urbana-Champaign, and Apple, that was foundational. Their work showed some pretty impressive performance gains using this code-centric approach. We're talking up to a 20% increase in success rates on some pretty complex tasks.
Wow, a 20% boost. That's significant.
Yeah.
Were there any particular types of tasks where CodeAct really shined, and were there any where it didn't seem to offer much of an advantage?
Their research focused on tasks that involved complex reasoning and multi-step interactions with different tools. And that's where CodeAct's ability to plan and execute those steps in code really stood out. They didn't go into detail about tasks where it didn't perform as well. But you can imagine that for very simple single-step actions, the overhead of generating and executing code might not be worth it.
That makes sense. So if the task is super simple, CodeAct might be overkill. But for anything more complex, it seems like it's got real potential.
And building on that initial research, we've got open source projects like LangGraph that are actively incorporating CodeAct. Their implementation streamlines the architecture a bit. They basically have this back and forth between a call model node, which generates the Python code, and a sandbox node, which executes it. It creates this nice, clean cycle of code creation and deployment.
So LangGraph is kind of like a CodeAct toolkit, right? It makes it easier for developers to jump in and start building their own code-powered agents.
Precisely. It gives you a structured framework and the components you need to get going with CodeAct.
That's pretty cool. And it highlights that this core idea of CodeAct isn't tied to just one programming language. Because we're also seeing JavaScript-based implementations popping up, like AgentScript. It takes the same fundamental CodeAct principles, but applies them to the JavaScript world. Their documentation puts it really well. AgentScript does exactly that. prompts an LLM to generate code, a subset of JS, and executes it in a dedicated runtime with resumability, state persistence, and interactivity, human-in-the-loop, baked in. So you've got that same idea of generating and executing code, but now you're leveraging the power and flexibility of JavaScript.
It's great to see that kind of flexibility, and it makes me wonder, for folks who are thinking about building with CodeAct, are there any best practices emerging? Like, are there standard ways to structure an agent's code that have proven effective?
Yeah, are there any architectural patterns that people are finding useful when building these code-driven agents?
Actually, there are a couple of interesting patterns that are starting to emerge. One is called vertical slice architecture. The idea here is to organize your agent's code around specific capabilities or areas of expertise rather than by technical layers. So imagine you're building an agent that can write blog posts and also manage social media updates. With a vertical slice approach, you might have a blogging slice and a social media slice. Each slice would contain all the tools, logic, and code specific to that function. This makes it way easier to manage and update individual capabilities without messing up the rest of the agent. And there was this quote from one of our sources that I thought really captured the benefit. If you want to create another version of the blog agent, I can just copy this entire thing and update to whatever blog agent v2. It makes the whole thing more modular and easier to maintain.
It sounds like a really organized way to deal with the complexity of building these agents.
It definitely is. And then for simpler agents, there's the single file agent pattern. As you can probably guess, this just means putting all the code for a specific agent into a single file. It might sound overly simple, but it turns out that this approach can be incredibly helpful, especially when you're working with AI coding assistants. Keeping everything in one place makes it so much easier for both humans and AI to understand and work with the code. One of our sources even said, the fact that you have one file to allow your AI coding assistant to quickly update your agent, I think is a massive win. So it really streamlines the whole development process.
Okay, so we're seeing some pretty practical approaches for building these code-driven agents. Now let's step back and look at the big picture again. What are the main advantages of adopting this CodeAct approach? Why should people care?
Well, the benefits are pretty compelling. We've already touched on the flexibility and power you get by using a full-blown programming language as the action space. It gives agents a much wider range of options for combining tools and implementing custom logic. Then there's the performance boost. We saw those studies showing higher success rates and potentially fewer steps needed to complete tasks. That's a big deal. And then there's this whole idea of self-debugging. Because the agent generates and observes its own code, it can often understand when errors happen and try to fix them in the next iteration. This leads to more resilient, more autonomous agents. And last but not least, there's the potential for better token efficiency. By planning and executing multiple steps within a single block of code, you can sometimes reduce the overall number of the times you have to interact with the LLM. And as we heard, this code calling allows you to save this results variable and then reuse it, and this can all be planned by the LM in one single LLM call, which can save you on computational costs. It's like getting more work done with fewer conversations with the AI.
So, more flexibility, better performance, self-debugging capabilities, and potentially even lower costs. Sounds like a pretty compelling case for CodeAct. But I have to imagine there are some challenges, right? It can't be all sunshine and roses. What are some of the things people need to be aware of when they're actually implementing CodeAct?
You're right, there are definitely some important implementation considerations. And at the top of the list is security. We're talking about AI generating and executing code, so you absolutely have to have strong safeguards in place. That means using sandboxed environments with very tightly controlled permissions to minimize the risk of any unintended or malicious actions. One of our sources even gave a pretty stark warning about a specific implementation, saying this will use the local evil function. You should not use this in production. This is not safe. So yeah, robust sandboxing mechanisms are non-negotiable.
Security is definitely a huge deal when you're dealing with AI that can write and run code. What else should developers be thinking about?
Another important factor is tool integration. For CodeAct to really shine, the tools that the agent can access need to be well documented and ideally have clearly defined interfaces. This makes it much easier for the LLM to generate the right code to interact with those tools reliably. And then, as agents start tackling more complex multi-step tasks that might span multiple interactions, state management becomes increasingly important. You need a solid way to keep track of variables, context, and the overall progress of the agent's reasoning across all those different code execution cycles.
So, to sum it up, secure execution environments, well-defined tools, and effective state management. Those are the key pillars for building successful CodeAct agents. Now let's take a look into the future. What's the trajectory of Code Act? Where's this all headed? And are there any limitations we should be aware of?
CodeAct definitely has a ton of potential, but it's not a magic bullet. It's not going to be the best solution for every problem. One of our sources made a really insightful point saying code is only good for tasks within the training set, so that a variant of the code structure. What this suggests is that for tasks that don't translate well into a code-based solution or fall outside of the LLM's knowledge base, other approaches might be more suitable. And another interesting development is the idea of combining CodeAct with parallel agent architectures. The idea here is to have multiple specialized agents, some of which might be using CodeAct, working together to solve a problem. One perspective we came across put it this way: complex problems always yield better results when tackled by teams of people with different specializations. The same principle applies to AI agents. Individual expertise combined creates exponentially more powerful solutions. Frameworks like Pydantic AI and Langograph are already exploring ways to build these collaborative multi-agent systems. It's like building an AI dream team where each member brings their own unique skills and approaches to the table.
That's a pretty cool vision for the future of AI.
Yeah.
A bunch of specialized agents all working together. It's like the Avengers of AI, each with their own superpowers.
Exactly. So while CodeAct is already a powerful way to build individual agents, its future might be even more interesting as part of these larger, more sophisticated multi-agent systems.
This has been a really insightful look at the world of CodeAct. So for our listeners out there, the key takeaway is that CodeAct is a new and potentially game-changing way to build AI agents. It gives them the power to generate and execute code, which opens up a world of possibilities. We've seen the potential advantages: increased flexibility, better performance, self-debugging capabilities, and maybe even lower costs. We've also talked about the importance of security, well-defined tools, and effective state management. And it's clear that this whole area of AI is evolving rapidly. It's going to be fascinating to see what happens next.
Absolutely. And as we wrap up, we want to leave you with a question to ponder. How might this ability for AI agents to code change the way we interact with technology and solve problems in your own field or area of interest? Think about the implications. Think about the possibilities, because this stuff has the potential to be truly transformative.